Let's now talk about maps versus objects. We all know what objects are. What are maps? Well, there's something new to ES6. But first, let's say, why are objects kind of bad? They're not all bad, but they're kind of bad, right? Well, first of all, the keys order are not guaranteed, especially when you loop. So when you loop, right, it may not display 2 with 2 as the first one. Okay, sometimes it does, but the order is never guaranteed. Second of all of your keys, the type has to be a string. If it's not a string, JavaScript will try to convert it to a string, right? So let's say for this number 2, JavaScript would do string 2 on it. Okay? But if you try to put, let's say, an array, it's invalid because when it tries to string an array, you just get an empty string. And you cannot have an empty string as a key. Okay. So those are some of the drawbacks. And also, you cannot do things like a for loop over it, right? And you can't really get the length of an object. You have to do like some trickery with object.keys and things like that. Now, to prove that they do convert these to strings, we can do something like console.log, capital O object.keys. So object.keys, whatever you pass in here, whatever object you pass in, it will return an array displaying the keys of that object. See? You see how all the keys are in strings? Okay, now let's talk about maps. How do we make a new map? Well, we have to use the keyword new, capital M map, then we pass in an array, and then inside that array are more pairs of nested arrays. And inside these nested arrays will be our key value pairs. So here, I can even do object 1. So I'm putting this whole object as the key. And let's do some random big number. Here, I can even do this async promise function. I'll even call it. I'll do promise, call it. Now it returns a promise. And its value, let's do NaN. And here, we can even have NaN as the key. And the value, we can instantiate a new person even. New person Phil, right? And then age will be 33. Do we have any errors? No, we don't. Okay, so unlike an object, we can now loop through this. We can actually just even do a for loop. For const, and I'm going to use array destructure here. When we destructure, the first variable, we get access to the map's keys. And the second one is the value that it holds. So for const key value of map1, we're just going to console.log key, comma, value. Okay, so if you look right here, it keeps it in order. Look, the order was the object and then this long key first, right here. Object, long key. Then this promise, which is fulfilled, and then its value is NaN, right here. Then here we have NaN, and the value is the person constructor, or an instance of it, actually. Okay, so all of that is kept in place. Okay. You can also do a for each loop through it. So you can do map1 dot for each. Okay. And you also get to the key and the value. Okay. And then you can console.log key value as well. See? So you can also do that. Now let's talk about some other methods. Let's say we want to set a new method in here. We can do a comma and then another array, or we can call the set method. We can do map1 dot set. It takes in 2 arguments. The first argument is the key. Let's do something cool like no. And the value, let's do undefined. Okay. And then now, what about get? Well, get, you put in the argument the key that you want, and it will return to you the value. So let's do console.log map1.get obj1. See, we get that key. But how do we get like this NaN right here? Because we can't just do promise 1. Okay. If this wasn't a function call, then we can do it. Okay. But since this is a function call, it's undefined. Okay. To get this, we have to use array destructuring. So let's test this. Let's do const, and let's just call this test is equal to map1, and then console.log test. Okay, so you see what it did was it extracted the first pair right here. So then let's call this pair 1, pair 2, pair 3. And then let's console.log pair 2. See? So now you have access to the promise as well. Yeah. If you just want to destructure pair 3, right? Remember, you can separate them by commas. So let's call this pair 3. See? And you still get that. Yeah. If you just want to destructure something on the inside, right, you can do something like this. Returns undefined. Oh, it should be one less comma. See? And it returns the string as well. Cool, right? Okay, now, unlike objects which does not have the length property, maps do, but it's just called size. So we're going to console.log map1.size. What should that be? Right now it's 4. There's 3, and then we added 1 more. Okay, so 1, 2, 3, 4. Not 5, sorry. I don't know why I said 5. And then let's say if we set in 1 more, we still get 4. Why didn't it go to 5? Well, because if we set the exact same thing, that doesn't work. What if we set no and no? Huh, why is it still 4? What if we set it's 5? Okay, so just like an object, map cannot have the same keys. Okay? So since we had no before, and we added another no, the size will not go up. Okay, let's talk about clear. It's like local storage. When you want to clear something, you just call it, passing in no arguments. You see that the size is now 0. Let's put everything back. Size is 5. What happens if we do map1.size is equal to 0? Nope. Okay, because .size is read-only property, so you cannot set this property. Okay, it has its own getters and setters. So unlike arrays where you can do array.length equal to 0, you can't do that with maps. Okay, I hope this basic intro was useful. And don't forget, maps do not replace objects. Right? If you look at this, it's now really hard to get the properties of this object 1. So when do we actually want to use maps? Well, we use maps 99.9% of the time when we want to assign a special key or identifier to an object. Okay. So imagine we are Facebook, and the object 1 represents our users. Like username, they have access to that. They have access to their own password and password reset, right? But internally, Facebook has a special ID for each user that the user cannot know, right? Like your special identifier tag. And the way to do that is map. Now, they invented map, and they also invented weak map. So why do we need weak map? Okay. Well, the only thing that's different in a weak map is that a weak map prevents memory leaks internally. So just by using the words weak map, JavaScript engine will actually garbage collect your variables and your memory references in a better way. But don't worry about weak map, because that's not used unless the object that you're assigning as a key in your map has like hundreds of thousands of properties and or methods. Okay, that can lead to a memory leak. But for smaller companies or for personal projects, just use map. And honestly, map is so new that 99% of the time, everyone's just going to use objects anyways. Okay. All right. I hope that was useful. Sorry for the tangent.